Hello, welcome back to the LOOC. In this segment and the next, we'll look at basic problem-solving techniques, how to develop algorithms using the process of top-down stepwise refinement, how to use the if and if-else selection statements to choose between actions, how to use the while statement to carry out actions repeatedly. We look at how to use counter-controlled repetition and sentinel-controlled repetition, and how to use the increment, decrement, and compound assignment operators. So, to start with algorithms, in general, we use computers primarily to solve problems. We solve problems by carrying out a sequence of steps or actions in a specific order, and therefore an algorithm is a procedure for solving a problem in terms of actions or steps to be taken or executed in a fixed order in which these actions are to be executed. A simple example is starting the work of a junior executive by getting out of the bed, then take off the pajamas, take a shower, get dressed, eat breakfast, and carpool to work. If we reconsider these steps in a slightly altered order, get out of bed, take off pajamas, get dressed, take a shower, eat breakfast, and carpool to work, we end up with our junior executive showing up for work soaking wet because he took the shower after getting dressed. And that clearly indicates that the order in which we take our actions is crucial for correct operation. The order of steps or actions is also known as control flow or program control. To describe algorithms, we often use pseudocode, which is a concise form of describing algorithms similar to English. They provide a plan of the application before we write it, and if written correctly, a good pseudocode is usually easily converted to program code, including C# code. There are three major control structures or constructs that we can use to set up the control flow of an execution. One is sequential, in which steps or actions follow each other sequentially as prescribed in the pseudocode or the program code. And the other is conditional or branch structure, in which case the flow of the program depends on some condition being true or false or evaluated to particular values. And finally, a repetition, iteration, or loop structure, which allows us to specify that certain actions are to be executed repeatedly. And when we modify the control flow from sequential, we transfer the control to a branch or to an iteration structure. UML uses an activity diagram to indicate a workflow of an application. This is the workflow notation was developed from the earlier flowchart diagramming technique. It consists of action state symbols, selection and merge diamond, and initial and final state circles. An example being shown here: to action, add grade to total, and add 1 to counter are indicated. The execution starting with an initial state, which is a solid circle, and terminating at a final state with a solid circle with a hollow ring around it. And nodes are associated with the actions, in this case indicating the corresponding C# statement. So total equals total plus grade, and counter equals counter plus 1. Generally, we build single entry, single exit control statements. which then can be connected to each other, is also known as control statement stacking. They can also be nested or embedded in one another, which is called control statement nesting. So after the sequential execution, the first major control flow construct is the single selection if statement. They specify that if a certain condition evaluates true, then a particular action is to be taken, otherwise not. So in pseudocode here, the example is if grade is greater than or equal to 60, then display paused. And following it is the C# program code if, and the conditional statement is in round parentheses grade greater than or equal 60, following the body of the if statement, which is a console write line paused. The C# code closely follows the pseudocode, and we can look at the workflow diagram of this example. The decision symbol is a diamond, and the workflow will continue following the guard conditions, one of which always evaluates to true and the other to false. So here is the UML activity or workflow diagram with the action of printing or displaying paused taken if the grade is greater than or equal 60, so the appropriate guard condition leads to that, with a note indicating the corresponding C# statement, and the other guard condition grade less than or equal 60, leading to termination without any display. So this is a single selection if statement, and the two guard conditions are complementary, so if one is true, the other is false, and vice versa. A double selection statement is a control flow structure in which a conditional statement is evaluated to true or false, and there are two different actions to be taken, one if the condition turns out to be true and the other if it's false. So the pseudocode example here is if grade is greater than or equal to 60, then we display paused, else a keyword indicating otherwise we display failed. Shown is also the C# code if the conditional statement in the round parenthesis grade greater than or equal to 60, and the true part of the if condition is the action is a console write line printing out paused. The else part is the false part of the if construct printing out failed. And we usually indent the body of the statements, and using a fixed amount of indentation. The UML activity of workflow diagram is indicated. This is a two-sided double selection statement, and two different actions are taken depending on the guard conditions being complementary. A shorthand for the if-else double selection statement is a conditional operator, or ternary operator is also known as, which is a shorthand composite for a double selection if statement. It consists of a condition followed by a question mark, and the question mark is followed by two actions separated by a colon, and the first is to be taken if the conditional expression evaluates to true, otherwise the second statement is to be taken. So in this case we create some output using a console write line, and what we are outputting itself is a conditional operator. It consists of a conditional expression grade is greater than or equal to 60, followed by a question mark indicating that if the conditional statement evaluates to true, then to be outputted to the console screen is the string paused, and colon indicates that if the conditional statement evaluates to false, then the string to be output to the console screen is a string failed. So the operand is a Boolean expression that evaluates to true or false, and the second operand following a question mark is the value of the expression if the conditional Boolean expression is true, and the second when it's false. We can parenthesize the conditional expression for clarity and provide proper precedence. In case of more complex scenarios, then there is more than one choice. We generally end up with nested if-else statements. If-else statement can be nested both in the true part of the if part of the statement or in the false part or the else part of it. In this example, the several consecutive ifs are nested in the else part, each one in the following, each one in the preceding ifs else part. So the first conditional statement is whether grade is greater than or equal to 90. If that's true, then we display an A. Else indicates the otherwise, the false part of the if, which itself is a nested construct. A second if is embedded if grade is greater than or equal to 80, in which case we have to display B. The grade is still not determined in other cases, so we have to continue with an else, in which we embed the third option. If grade is greater than or equal to 70, we display a C. We are still not completely covered all possible scenarios, so a next if checks if the grade is greater than or equal to 60, in which case we display a D, and the final else, display F, closes the construct. The pseudocode is written in C# as indicated, so there's a first if, and then within the else part of it there is a second if embedded, which in turn has an else part in which the third if is nested, and so on. Note that ifs and else that are vertically under each other belong together. So every if is associated with the nearest else. It can be somewhat confusing looking, so most programmers prefer a straight line arrangement of else if statements. This is the exact same code but clearer. If we take the first if followed by an else if as the second if, an else if for the third, and else if for the fourth, and the final else. So this is the exact same code as the previous, but each consecutive if is placed on the same line as the previous if else component, creating a clearer layout of the code. An else is always associated with the immediately preceding if, unless braces indicate otherwise, and if we don't pay attention to this requirement, we end up with a problem called the dangling else problem. Here is an example: an if-else double selection statement, two ifs followed by an else, and as written it seems as the else is associated with the first if. If x is greater than 0 is the conditional expression, and otherwise else console right line x is less than or equal to 5. However, this is incorrect because the else, despite its layout, is not associated with the first if but with the second one, the nearest. So correctly rewritten is the second version that shows that the if and else, the second if and else form one double selection statement, and the first if does not have an else part. If we want to associate with the else with the first if, then we have to include braces that form a block. Braces can be placed both the if and the else part, and they are necessary in case of ifs are embedded, some without and some with else conditions, and we make to set up the correct association. And equally, if more than one statement is to be executed in either the if or the else part of a double selection statement. The braces form a block, and here is an example when the else part of the statement contains more than one commands. Two console write line failed, and you must take this course again, are to be executed in the else part of the selection statement. Without braces, only the first line would be part of the else component, and the second write line would be executed every single time regardless of the if or else statement, so it wouldn't be part of the selection structure. So to make both console write lines part of the else, we have to place them in a block. The same would apply for the if part if there were more than one lines there. Confusing ifs and elses and not indicating proper blocks would lead to logic errors, which can either crash a program, in which case a fatal error, but even if they don't crash, a non-fatal logic error would lead to erroneous execution. And therefore it's advisable that we always place if and else and other compound statements with their braces, and often comment their ends before placing in the body of the statements. We should never place a semicolon immediately after an if condition, because that would create an empty body for the if, and therefore the following statement would always be considered as either independent of the if or part of an else, and we would never get a statement executed when the condition is true, leading to a logic error. The third important control flow construct is the repetition, iteration, or loop statement. It allows to perform an action repeatedly. Example pseudocode stands here: while there are more items on my shopping list, put next item in cart and cross it off the list. Clearly indicating repeated actions. A C# example would be using a variable product of type int initialized to 3, and a while statement with a conditional statement following in round parentheses product less than or equal to 100. So while this conditional statement executes to true, keep repeating the body of the loop, which is product equals 3 times product. In other words, we keep multiplying the value of product by 3's, generally creating 3 powers in this case until the first 3 power that exceeds 100, in which case the loop terminates. If there is no instruction in the body of the while statement, or there is no instruction there that changes the loop variable in the previous case body, then we get an infinite loop. So if the product equals 3 times product statement were not there, we left the product unchanged, then we would create an infinite loop which would hang the application indefinitely and would then have to be terminated manually. Again, a major logic error. The activity diagram in UML for repetition statement is shown. The merge symbol is also a diamond. So in this case, the conditional statement is the second diamond, the decision statement deciding whether product is less than or equal to 100. While that is being true, we carry out the action of tripling the product value, the node shows the corresponding C# statement, and we keep looping through this, returning to the control flow and merging into it repeatedly until the first time the product becomes greater than 100. There are multiple ways we can set up a repetition or iteration or loop structure. One of them is called a counter controlled repetition. In this case, we use a counter variable. So here is a problem. A class of 10 students took a quiz. The grades, which are integers in the range of 0 to 100 for this quiz, are given. We have to determine the class average on the quiz. So the solution, which is an algorithm, must input each grade, keep track of the total of grades that are entered, and perform an averaging calculation and display the result. This is called a counter-controlled repetition. We use a variable that serves the purpose of a counter, and it's also known as a definite repetition because in this case the number of times the iteration happens is known before the loop begins executing. Generally, we have to create the right algorithm for the solving of a problem, and that's really the hard part. Once the algorithm is set up correctly, translating it into C# code is normally a relatively simple task. So in this case, we are going to write an algorithm for the gradebook application. We already created one in an earlier segment. The algorithm in pseudocode is indicated here, so we have to set the total to 0 and the grade counter to 1. Then we are going to create a loop, a while loop, while the grade counter is less than or equal to 10. We repeatedly prompt the user to enter the next grade. We input it from the user. We add it to the total. It's a slowly growing grand total of all the scores, and we also increment the grade by 1. We keep doing this until the grade reaches 10. Once it goes beyond 10, the loop terminates and we are moving to the final stage of the execution. We compute the class average as the total divided by 10, and we display the class average. Here is the code of the gradebook class that will display the average, carry out this algorithm. It will have an auto implement with property called course name. We'll have a constructor as before containing one argument, a string for the class name, and a greeting display message. We did already this part. The new component is the determine class average method. It uses 4 local variables, total, grade counter, grade, and average, and has 3 phases: an initialization phase which initializes the total to 0 and the grade counter to 1, a processing phase which is the while loop, in which the grade counter runs as long as it's less than or equal to 10, and we enter the grades, convert it to integer, add to the total, and increment the counter by 1. That will be end of the while loop. And then finally the termination phase consists of computing the average. Note that as stands it is problematic because of integer division. We are going to look at that, and then display the total and average of the grades. The code statements are separated by blank line for readability, and we assign variable values by starting the initialization, which is very important because if we try to use a variable before it's definitely assigned, we have a compilation error. And generally we initialize sum type variables, totals to 0 and counters to either 0 or 1 depending how we use them. We are also going to write a a test application which consists of a gradebook test class which contains our main method. It creates a new gradebook object. We display the greeting message, and then we determine the class average. So to do so, we need to go to C# Express. Our application is called Gradebook app, and it contains a gradebook file and a gradebook test file. The gradebook file will contain the gradebook class, and the gradebook test file will contain the gradebook test class with the main method. So let's start writing the gradebook class first. The first thing we add to the class is an auto-implemented property course name. So auto-implemented property course name. It's a public property of type string and upper camel case naming convention, and we indicate that it is supposed to auto-implement a set and a get methods. This implicitly creates a private instance variable for course name and implements the get accessor and the set mutator, and we don't need to write the code because it's auto-implemented. We also have to add the constructor, so constructor that initializes the course name property. As always, constructors typically are public. There are very rare deviations from that, but typically are public. Their name is the same as the name of the class, and they can take arguments, in this case one string argument, which is the name of the class. Laying out the structure first, this is the end of the constructor, and the body of the constructor simply assigns the course name property to pass the name parameter. The welcome message is next. Display welcome message to the gradebook user. This is a public message, a void return type, so it does not return any information, and its structure is laid out first, and it simply uses the property course name, gets the name of the course. So it's a console write line method that just displays our message as a string. So welcome to the gradebook 4, and then a new line escape character and our first and only content parameter, followed by an exclamation point and another new line, and then our actual content character, which is course name, the course name property, and that completes the welcome message. And now comes the new method to determine the class average based on 10 grades entered by the user. This will be also a public message, void return type, and it will be called determine class average. Here is the structure laid out, and determine and method determine class average. The body of the method uses local variables of integer type total, which is the sum of the grades entered by the user. A second one's called grade counter variable, which is number of grades entered by user, or number of the grade entered next to be entered next, maybe clear it that way, in the grade, which is the grade value entered by the user, and we need another variable for average. I noticed that I didn't really type int very correctly there, which is average of the grades. And made another error here, that I really wanted the second variable just be called grade. There. So nicely commented, so that we know what we are doing, and also that we can share the code with possibly other team members who participate in writing this program. So now gets the three phases. Initialization phase first, in which we set total to 0 because it's sum. Initialize the total, and we also set grade counter to 1 because it's a counter, and in this case we start with 1. Initialize the loop counter. Then comes the processing phase, in which we use a while counter, a while loop, while grade counter, that variable is less than or equal to 10. That means that we loop 10 times, so this is a counter controlled loop and a definite counter controlled loop, because we know in advance the number of times the body of the loop will get executed. We need to answer the grades, so it will be a write method because it's an input. So enter grade, and we can pause. This is from the user, and then we get the actual grade variable, local variable equal to, we have to convert to int 32 what we read in from the console, and that's a read line. And that's to read the grade. Once done, we are ready to carry out the addition, so total equals total plus grade that the user just entered, and this add grade to total. And very important not to forget incrementing the counter, so grade counter equals grade counter plus 1. That is that we increment by 1. That completes the while loop. So now we are ready to the termination phase of the algorithm. It consists of computing the average as total divided by 10, and an important comment here that integer division will take place, which always yields an integer result, meaning that the average will always come as an integer, basically rounded down closest to the next lowest integer, which might be okay in some cases, not in some others. We can fix that. And part of the termination phase, we also display the total and average values. So it's a console write line. Start with a new line escape character. Total of all 10 grades is, and our first input, first and only input content string total, and the second will be also a console write line, in which we say that class average is, and we are ready to place our format string, and our constant string is the value of average. And that it constitutes the end of the end of the method determine class average, and that completes the class. So let's save this. As a quick check, if we made any error, we can build the solution at this point. Since there's no error message, we completed the public class gradebook, including the determine average method. To be able to test the application, we have to go to the gradebook test, which actually is misspelled a little bit, so probably I want to actually correct that. So gradebook test, and that's to be corrected, so save that. And the class gradebook test contains the main method, which will test out the class. Let's save everything and let's rebuild the solution to make sure that everything is correct. And within the main method, we are first going to create a grade book object. We call it my grade book, and pass course name to the constructor. So gradebook is a class and therefore data type is available. The variable is called myGradebook. As always, creating a new object requires the new keyword and then the constructor, which is also available as we wrote, and we have to pass in a string, so let's call it CS101, introduction to C# programming, name of the course. And once that's created, then we do two things. One of them is myGradebook object. We invoke the display message method. Doesn't need any parameter, any argument, because the gradebook property is already there. And secondly, we are going to invoke the determine class average method, which also doesn't take any parameter, because there's a fixed number of 10 students in the class, which is the end method main, and we are at the end of class grade book test. To check the correctness of everything, let's build a solution. It succeeded, so we can test the application by hitting Ctrl F5, and then it comes up and it asks for the grades to be entered. So maybe I position it here. So we have to enter 10 grades. Let's say they are 88 and then maybe 79, followed by 95, followed by really good students gets 100, 48, that's not so good, 88, 92, say 83, and then 90 and 85. There's the 10th grade, the last one, so we expect the total, which is 848, and the class average is 84. As I mentioned before, in this case, since we are carrying out the average equals total divided by 10, here is an integer division. The result will be integer and it will be rounded down, which might be acceptable, so we can consider the average about 84. However, if we want to correct this, we need to basically change the type of the average from integer to some of the floating type options such as double, and then the total divided by 10 is still integer, so it has to be cast to a double type like that. If we do that, then the result will be no longer integer, it will be converted to or cast to the type double. So if we hit Ctrl F now and we enter the grades again, which were 88, followed by 79, followed by 95, 100, 48, 88, 92, 83, 90, and 85, the last grade, then we get the total of the grades is 848 and the class average comes out this time as a real number 84.8, which is the correct value. So this cast was needed to avoid the integer division which always is an integer. Result, maybe I add it as a comment. Cost needed to double. So that's the first version of our gradebook application that determines the class average. Here is again the example that we also went through. A comment is that dividing two integers is an integer division. The result is truncated, that is rounded down, and it can be an error. If we want correct results, then we have to class it. In the next segment, we are going to look at sentinel controlled repetition, which is another version of the repetition structure.